It's your friendly math tutor, Miss C here, and today we are simplifying fractions, but not just any fractions, fractions that look a little scary and have variables. So let's go ahead and get started. So the good news is our rules that we already learned about fractions remain. We just have to be a little careful about certain things. So anytime we have fractions that are added like this one or subtracted, we have to get a common denominator to be able to add the fractions together. What I'm noticing here is my denominators are not the same. So what I know is my common denominator is going to look like this. So we're basically using the strategy that we multiply one denominator by the other denominator's value and vice versa. So, pro tip, anytime you have an addition sign or a subtraction sign in the denominator, I always parenthesis it straight away. Those values that are separated by addition and subtraction have to travel together, that whole expression. So, let's go ahead and get started. To make this fraction have a denominator of a times 1 plus m's quantity, I need to multiply the denominator by a. But I can't just multiply the denominator by a because I've changed the value of my fraction now. I also have to do it to the numerator. So you might have heard the phrase, what you do to the denominator, you do to the numerator. And that's because what we're essentially doing is creating an equivalent fraction. So a divided by a is 1. So we've actually added nothing to this fraction. We've just changed the way it looks. To this fraction, I'm still trying to get my denominator of a times the quantity 1 plus m. 1 plus m gets multiplied here. And then for the same reason, we're doing the exact same thing to the numerator because we are creating an equivalent fraction. And now we're ready to simplify. We are going to know that our denominator, look, it's exactly the same. So we can write this as a times 1 plus m here. And because our denominator is common now, we can go ahead and multiply a times a, which is a squared, plus m times quantity 1 plus m. Now, this is not simplified enough, so I'm going to go ahead and I'm going to distribute this m throughout to get the parentheses out of the numerator. So m times 1 is m, plus m times m is m squared. So that numerator is fine. So one of the ways you could leave your answer is like this. Another way that you could write your answer would be to distribute this a to both terms, okay? So when I do that, I end up with a squared plus m squared all over a times 1 is a times a plus m, which is am, okay? I think depending on what your teacher is asking you to do and what you're doing next with this, either one of these answers would suffice, although the bottom answer is the most simplified answer. All right, let's look at a situation where we have a fraction divided by a fraction. These can look pretty ugly, I'm not going to lie, to start with. And I think the easiest way to manipulate this fraction in order to simplify it is to simplify the fractions in the numerator and the fractions in the denominator separately first. So basically, we will end up with a single fraction in the numerator and a single fraction in the denominator. So to do that, I'm noticing that my denominator has an x in this term and a y in this term. I know that because I need them to be common, I'm going to have a denominator of x times y, right? Because I need both of these values to be in the denominator. So to that end, I'm going to multiply the denominator here by y. What I do to the denominator, I do to the numerator because I'm creating an equivalent fraction. Okay, on this one, I need this to be x times y, so I'm multiplying by x, doing the same to the numerator. Now, I'm noticing that I'm going to have the same denominator in the fraction in the greater denominator. So I'm going to go ahead at this point and just do the same thing and get a common denominator all around. All right, now I'm going to go ahead and I'm going to rewrite my top fraction. And I know that my denominator is going to be x times y, right? Because y times x is the same thing as x times y, and y times x is x times y. So I'm going to rewrite this as xy in my denominator, and then I'm just going to multiply. 3 times y is 3y. Remember, in math, we always write the coefficients first, minus 4 times x, which is 4x. Okay, you might be wondering why I wrote x times y in the denominator instead of yx. Either way is fine. I have been trained mathematically. You always write x first. there is nothing wrong if you want to go ahead and write the denominator as yx. They are equivalent. I'm going to do the same thing in my greater denominator here. I'm writing xy as my denominator, and now I'm going to multiply 3 times y is 3y, plus, because I've got a plus sign here, 4 times x, which is 4x. Okay, we're in a really great shape here. We now have our two fractions that are single fractions in the numerator and denominator. So our next step is to deal with this fraction in the denominator. And quite frankly, I just want it gone, because when I have fractions stacked on fractions, it makes calculations more challenging. So the way I get this gone, and by gone, I mean it's not really gone, is I'm going to multiply it by its reciprocal. I want to turn this whole denominator into a value of 1. So I'm not changing the value of my fraction, just changing the way it looks. Big theme in math. So to make this equal to 1, I'm going to multiply this fraction by its reciprocal. So its reciprocal is itself turned upside down. So I multiply it by xy times 3y plus 4x. Now, hopefully you notice that there is an addition sign here. Anytime we see that, when we're multiplying, we just parentheses these values. Okay, great. Now, to keep this equivalent, I have to multiply the numerator by exactly the same thing. So I'm just going to rewrite this part of my fraction up here, because what, again, I'm doing is I'm multiplying by 1, which means I've changed the way my fraction looks, but I haven't changed its value. Okay, great news. This whole thing in the denominator equals 1. 3y plus 4x divided by 3y plus 4x is 1. X times y divided by x times y is 1. So I'm going to go ahead and rewrite this as 3y minus 4x times xy. And I'm not putting xy in parentheses because it's being multiplied. There's no addition sign there, although you could, and it would not be incorrect. So rewriting it this way is correct. Or if you wanted to do this, that is also an equivalent form. And now I'm noticing something really interesting. Look what I have in the numerator and denominator. They are being multiplied by my binomial, which means that I can divide them. So x times y divided by x times y, that equals 1. Right? So those are going to disappear. So what I'm left with in the numerator is not 3y, it's 3y minus 4x divided by 3y plus 4x. So that is your most simplified form, right? Just a reminder, this became a 1 when we divided that. So we took something that started out a little rough and we made it into something that's a lot simpler and would be a lot easier to work with. If you found this video helpful at all, please like it so it shows up for other folks. And make sure to subscribe so you don't miss a video. Till next time, remember, you've got this.